Alright guys, so in this video I'm going to look at just a few examples dealing with systems, and you have these in your worksheet. There's no real order that I'm doing them in. I just picked a few to complete online. So number 4 here, it says 3 blocks, light connecting ropes and a light frictionless pulley comprise a system. As shown in the figure, an external force of magnitude P is applied downward on the block, causing block A to accelerate downward at a constant 2.5 meters per second. So, since it says we're accelerating in this direction, I'm going to go ahead and call that positive. Now, if I were to deal with this as a kinematics problem, I would have to make sure that anything moving in that direction for kinematics is also listed as positive. The tension in the rope is equal to 60 newtons. What is the magnitude of force P? So to start, I just want to label all of the forces on my blocks. So here we have block C. C has a force of gravity. It also has a tension force, where the tension equals 60 newtons, and the force of gravity, I don't know what that is, but I know I'd find it by doing mg, mass times the acceleration due to gravity. Now, I don't believe there are any other forces on C. It looks like that's it. For block B, I'm going to have a force of gravity for B, which is equal to B's mass of 18 kilograms times 9.8. It looks like B also has a tension pulling down, which is 60 newtons, because that's the same rope. And there is a tension pulling up. I do not know what that tension is. I'm going to just call that T1, just so I keep it straight from this tension here, because it's not equal to 60. And then I have for A has a force of gravity, which is going to be equal to 12 times 9.8. It also has a pull P, which is what I'm trying to find. And it has a tension force. And this tension is going to be the same, so it's going to be T1. Now, if my sign convention is this, that I want to look at the net force on everything. So the net force on my system is going to equal to P, it's going to be equal to P plus 12 times 9.8 minus T1 plus T1. Because this is the same string, those are equal and opposite forces, they would cancel in my net force equation. Then I have minus 60 newtons minus 18 times 9.8 plus 60, so it turns out those 60s cancel as well, minus mg equals the mass of my system. Now the mass of my system is going to be equal to m plus 18 plus 12, and then my acceleration is 2.5. Now I need to think when I'm doing these problems, should my acceleration be positive or negative? Well, I set my sign convention in a direction to where my acceleration is going to be positive. Okay, that's what the problem told me there. Now, from here it looks like I have two unknowns, the mass of C and the pull P. So I cannot use this equation yet. In order to find P, it looks like I'm going to have to find the mass of C, and that's also what B is asking me to do here. So I'm going to do part B first. So to find the mass of C, I'm going to isolate this system and write Newton's second law for just system C, or just block C. And that is 60 minus mg equals ma, or Newton's second law, so mass times acceleration is 2.5. So now I just need to solve for m. G is 9.8, so 60 minus 9.8 m equals 2.5 m. I need to add 9.8 m to both sides, so 60 equals, I'm going to do that, we get 9.8 plus 2.5. 12.3 m. So now I divide by 12.3, and m equals 4.9 kilograms. So now that I have that mass, I can go back to my net force equation and actually find P. So it looks like, I'm going to simplify it here, P plus 12 times 9.8, 117.6. Now the minus 60 and the plus 60 cancel. So now I'll get minus 18 times 9.8. This is 176.4. And then minus, right here, 4.9 times 9.8, 48, equals my total mass. I'm going to go ahead and add that here. So I'm going to say 4.9 plus 18 plus 12, and that gives me 34.9. I'm going to multiply that by 2.5, so the right side of my equation becomes 87.3. Now to solve for P, I'm going to simplify all of these values, combine my like terms. 117.6 minus 176.4 minus 48. Okay, I get P minus 106.8 equals 87.3. Now to solve for P, I add 106.8 to both sides, and I get 194 newtons equals P. Alright, number 5. It takes, what is the mass of the block on the left? There's no friction in the pulley, and the rope is very light. I'm going to start by drawing a free body diagram for my system. So I have tension here and here. This 100 kilogram block has a force of gravity, and this block has a force of gravity equal to mg. This force of gravity will be 100 times 9.8, or that equals 980 newtons. Okay, so it looks like we have some information to find our acceleration. My net force equation would look something like this: 980 newtons. Then we would have minus t. I'm going to set my direction of motion there. So 980 minus t plus t minus mg equals my total mass, which is 100 plus m times my acceleration. I do not know my acceleration, so what I need to do is use some of this extra information to find it. It says we move 1 meter, so my displacement is going to be 1 meter. My initial velocity is 0. It takes 0.53 seconds to reach that, and I'm looking for acceleration. So if that's the case, I can say delta x equals 1/2 at squared, and since my initial velocity is 0, that plus vit drops off the equation. Excuse me. So a is going to equal 2 delta x divided by t squared, or 2 times 1 over 0.53 squared. When I do that, I get an acceleration of 7.1 meter per second. Now, since I know my acceleration now, that's going to allow me to plug it up right here and find mass m. So 980 minus mg equals 100 plus m. When I'm talking about the system, I have to use my system mass times my acceleration of 7.1. So now I'm just going to do some algebra. So this becomes 710 plus 7.1 m equals 9.8 m. This is 980. So I'm going to subtract 710 from both sides, and I'm going to add 9.8 m to both sides. So that gives me 270 equals 16.9 m if I did my math right. Now I'm going to divide by 16.9. So 270 divided by 16.9. I get a mass of 16 kilograms. Okay, so here we have this frictionless system with a 6 and a 4 kilogram block connected together. I went ahead and I drew the free body diagram, and I went ahead and I found important values here to solve the problem. This 58.8 is the force of gravity for the 6 kilogram block, and I just knew I would use sine of 30 to get FGX. I'm only concerned with FGX for each one because FGX is what lies along my direction of motion. The normal force being equal to the FGY in each case probably is not going to be very useful, and the ramp is frictionless, so I don't need to worry about friction in this case. It says, what is the magnitude of the acceleration of the 9 kilogram block? Well, I'm going to start by writing my net equation for everything. So I'm going to start here. 88.2, that's the force of gravity of the 9 kilogram block, minus T plus T. I'm not going to write that because those cancel. Then I have minus T2 and plus T2. I'm not going to write that because those cancel. What I will write is minus 39.2 sine 30 minus 58.8 sine 30. Now there are no other forces pulling it down the incline opposite of this gravitational force, so all of that must equal the system mass, which is 19 kilograms, times A. Now from here we can just solve for A, and we get 88.2 minus 39.2 sine 30 minus 58. You get an acceleration of 2.1 meters per second. Now, part B, it says, what is the tension in the wire connecting the two blocks on the incline? So here's where I have to pick a system. It says it wants to know this tension. Now, in order for me to isolate this system, I need to know this tension up here. And since I don't know that, I don't want to make extra work for myself. I'm not going to calculate it. So I'm just going to isolate this 6 kilogram block here. So the net force on the 6 kilogram block is going to equal T2 minus this 58.8 sine 30, and all of that equals the 6 kilogram block times the acceleration of 2.1. So when I do this and solve for T2, I get 6 times 2.1 plus 58.8 sine 30, or times a half. It's going to equal 42 newtons. Okay, the last problem I'm going to do deals with friction. That's why I wanted to go over this one. It says package A has a mass of 3 kilograms and can slide along a rough plane inclined at 30 degrees. The string acts on the package parallel to the surface. The coefficient of static friction between package A and the plane is 0.4. So I'm going to go ahead and write mu equals 0.4 here. What minimum mass should package B have in order to start package A sliding up the ramp? So because it says just to start it, I need to basically find that maximum static friction force. So let's start by just drawing the forces on A here. I want to set a direction of motion as that is positive. So for block B, B is going to have a force of gravity, and there's going to be tension here. That's the same tension here. Now I know block A is going to have a force of gravity equal to 3 times 9.8. Now since this is 30 degrees, that means that this angle is also 30 degrees. So here my FGY is going to be 3 times 9.8 times the sine of 30. Times the cosine of 30. And that's going to be equal to my normal force. Now my FGX is going to equal 3 times 9.8 times the sine of 30. And then of course we will have a force of friction. Now the force of friction I'm actually going to have to calculate using mu times the normal force, and the force of friction is going to equal 0.4 times my normal force, which is 3 times 9.8 times the cosine of 30 degrees. So when I do that, I get a frictional force of 0.3. Actually, I'm just not even going to fool with calculating that yet. So looking for this mass, so I'm going to write my net force equation for the entire system. So mg minus t plus t, those cancel. I'm not even going to write it here. Minus the force of friction. So I'm going to say 0.4 times 3 times 9.8 cosine 30. Now I don't like to do a lot of math until the very end. I kind of just like to write it out. That's just my preference. So this is mg minus this force of friction minus this gravitational force in the x direction. So 3 times 9.8 times sine of 30, or 1/2. All of that equals 0 in this case because I don't want it to move just yet. I'm talking about static friction. Now eventually this mass that I solve, as long as it's greater than that mass, then basically it will be able to start the package sliding, or get it started there. So let's see. Now I'll just solve for m. No problem here. M is going to equal, I'm going to go ahead and simplify all of this, but it's going to be all of that divided by 9.8. So 4 times 3 times 1 cosine 30. So once you simplify all of this, you end up getting about 25 over 9.8, and that equals 2.5 kilograms. So that is the minimum mass that B can have to get the system to move. Alright, I hope this helps, and let me know if you have any questions.